Welcome back, everyone. I want to thank Romina and Morgan, as well as the ET staff, for leading that breakout session. We heard it was amazing, and hopefully we have a lot of schools ready to come up and share with us. I'm going to hand this back off to Edgar to kick off our Q&A wrap-up session.
Sure. So excited to be back. How are all the schools doing? I have some amazing pictures that have been coming my way. So I'm going to be sharing a couple of them with you. But before I do that, I do want to introduce the people that are going to be with me during this part of the agenda. And it's going to be Amanda and Romina. And I do want them to introduce themselves a little bit, talk a little bit about what they do before we start getting into what you guys did. Go ahead, Amanda.
Hi, everybody. I'm super excited to be here with you guys and see all your bridges get tested. I'll keep our intros pretty brief here so we can get to that as quickly as possible. But like Edgar said, my name's Amanda, and I am coming to you guys from Minnesota right now. But I do go to school at the University of Notre Dame, and I majored in civil engineering there with a minor in energy studies. So kind of my passions within civil engineering are structural design, construction management, which is what I'm actually going to be focusing on in my full-time job at a company called Weiss Builders here within the next couple months. And then I also just am very interested in renewable energy, so focused on that within my minor at Notre Dame.
Thank you, Amanda. Amazing. Awesome credentials. Let's move on. Romina, how are you, Romina?
Hi. So my name is Bermina. I just graduated from Virginia Tech, but I'm coming to you guys from Virginia. I'm a double major, so I'm majoring in civil engineering and Spanish, but within civil engineering, my focus is structural, and I'll be continuing my education to get my master's in structural design. And within, kind of touched on that already, but structural engineering, construction management, and sustainability are some of my interests. And I have some pictures there. I have a picture of me on a crane, on a tower crane, and also when I was studying abroad, visiting a bunch of different bridges in Europe. So that's kind of like my journey of how passionate I am about engineering and bridges. So, but yeah, I'll let you guys share everything. So that was kind of a brief introduction.
Thank you, Romina. So right now, I understand that there are teams. So right now we have people in Buffalo State at an event, and I understand that they are ready to share. Joanna, how are you from New York City? I hear that you have two teams ready to test over there. Is that true?
See, I'll highlight,
I
spotlight.
see her. Yep,
There
the
we
spotlight.
go.
How you doing, gentlemen? Good morning.
Good morning. I am here with several teams who want to show you their bridges, and I'm going to hand it over to team one first. So you can tell us who you are and talk about your bridge.
My name is Geet Malang. I'm from International Preparatory School at Grover, Cleveland. And the bridge we made is we basically tape wooden sticks so it can compress together so it holds more weight.
Let's see it.
That looks great.
It does look good. And I see you went for triangles. I see that. Is that road deck 3 inches? Did it stay within the constraints?
Yeah.
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 Talk to me about those. Yeah, I see it. Talk to me about those dowels on top. What are those dowels for? What was your thought about them?
Oh, the dowels. So I put that as basically as a aesthetic. It doesn't really do anything within.
Which, which is important.
Yeah. Wait, yeah, I have a question. What was like the hardest bridge you ever made?
Uh, so what are the are we talking about in real? I'm assuming we're talking about real life, right? So I worked on the Third Avenue bridge project here in New York City. So the only bridge that I ever actually worked on here, but it was extensive because we went from what they call soup to nuts. So we had to take the old bridge, and I'll show a little later. I'm going to show you some pictures, but we took the old bridge out and we had to put a new one in, right? And I think I mentioned earlier that because access space where you can build a bridge in New York City is so limited, we had to build it out in Alabama. Take it from Alabama, float it up the eastern seaboard 11 days, 11 days. So it had to be like perfect weather, right? And then it had to go up the East River. Challenging because number one, right? Think of the bridge that you have in front of you that you built. It was much bigger and you had to remove it, right? You would need a special team to demo it, otherwise it could fall, right? Then we had traffic patterns that we had to divert. We had to work with tides. I mean, there were so many things involved. And what you'll learn if you work on bridges is that every single project has its own nuances, right? So every different one is going to have its different challenges. Sometimes we even look at bridges that are curved, right? Sometimes those are for aesthetics. Sometimes they serve structural purposes, right? So enough about, let's see how you're gonna load this.
We have some other students who are gonna showcase their bridges, but we just wanted to show you that this bridge held this huge bag. I
No
don't know,
way.
Amazing,
40 pounds,
amazing.
Great.
standing strong. So let's give a shout out to this team. What was your high school again?
International.
So can we do another team or two? Would that be okay?
Yeah, absolutely, absolutely. Please.
Good. Well done, guys.
Thank you,
Great job.
gentlemen. Well done, well done.
Um,
It's awesome. Did she say 40 pounds?
and you
Mhm.
guys want to come up and showcase your bridge? What? You want to test yours? Okay. Can you talk
That's
I
about
like-
impressive. Look at this one.
Oh, this one's a little different.
I love it.
Lots of triangles here.
Hello,
Good
we're
morning.
from Millersville North, and this is our bridge. This is the Delta Bridge. So it has a lot of triangles in it, so it's really strong.
That looks great.
Amanda, why do you think? What do you think of that?
I think that's gonna perform really well, like you guys said. Lots of triangles in there, so it should be pretty strong and balance the tension and compression really well. I also love the name you guys gave it. That's super creative. So well done with that too.
Thank you.
I also
you
like
show us
the
the bottom? I'm just-
symmetry of it.
Mhm.
Yep. Thank you, Romina. I was going to ask, what do you think about the bottom of that bridge, Romina?
I like how
What's
they
the
have
little bit?
the crossing over from what I can see, but I don't know what they put like wrapped around the joist there with the red. I'm not entirely sure. Maybe they can talk about that a little.
Wait, sorry, what? Can you repeat that?
So what are the red like marks on there?
Oh, those are orange pieces of tape.
Mhm.
Pieces of tape.
Got it.
And you put them around the joints?
Yeah, so where the popsicle sticks overlap, that's where we put the tape.
And did you also use hot glue or just the tape?
Yeah, so we primarily use hot glue and then we overlap the popsicle sticks, and then we use tape to reinforce the joints.
That's awesome. Yeah, that's what I would do as well. Good job.
Looks pretty strong. How much weight did that hold?
Let's see what this Delta Bridge can do.
Oh,
Wow.
Wow, it didn't even move.
oh.
Not budging.
Did not move yet, and they're loading it, which is exciting. Are you guys listening? Maybe it's cracking. Is it making any noise? Do you hear it?
No,
Especially where
no
it's loaded.
Nothing yet.
Perfect.
Pay attention to the pattern of the deflection too as you add more weight.
Solid.
Holding strong. Look at that.
How much weight is in that bag already? Are we going by textbooks?
40
How many
pounds.
textbooks?
40
40
pounds.
pounds.
40 pounds on the bridge right now.
Wow.
Nice.
Wow.
Good job.
I'm still not-
Williamsville North, amazing. Amazing job. Well, I see you're still adding textbooks. I love it. That's how I loaded the bridges in my school.
Wow.
Nice.
Nothing.
Amazing.
That's impressive, guys.
Very, very impressive. Weight
I
to strength
love how
ratio of
you
that bridge is
guys
awesome.
paid attention to the aesthetics of the bridge as well, because that's something that you definitely have to look out for in the real world. So good job. That's
Thank you.
awesome.
Thank you very
Thank you,
much.
Williamsville. Thank you.
Okay. All right. I don't think we have time to do all the testing on camera, but I'm going to let each team come up and just briefly give you a 30-second overview of their bridge and where they're from.
All right, we got a team from Clymer, Panama, the best team out there. I mean, we came out here to compete, and this bridge is here to compete. That's what I'm saying.
What?
All right, we got
What's the mascot of your school? What mascot is your school?
what
Is it
is
Wolfpack? Is that right? The
Wolfpack.
Wolfpack? All right, Wolfpack.
All right.
this year? We're the freaking best in the country. The bridge. All right, on to the competition bridge. The Faith Bridge. All right. It's not held together by glue, tape, sticks. It's held together by faith. And that's what we're here to do. We have faith in our bridge to win this competition. It's a war.
Let's go.
Yes.
Let's go, Wolfpack.
Thank you guys. Well done.
Looks great.
Well done.
Never seen a bridge held together by faith. That was
I
that was
love that
cool.
confidence.
That was cool.
I don't know that. That was cool. Good morning. How are you?
I'm Lily, and this is the team from Panama Central School.
All right. Hi, Lily. Welcome, Panama Central School.
So we use this guy's design. He has built bridges in the past, and this is a design he says that works every time. We got a lot of triangles, because that's good. We also got a road here. I call it the horseradish bridge because it's strong and it gets ya. So, yeah,
I like it.
I think we did a really good job.
I agree.
I like the name. Clever. Yep.
right,
It
we're
looks
gonna
good. Good job.
We think you did a really good job too.
Ooh, this
Oh,
one looks
good.
pretty different.
No,
Okay.
our bridge is a little unique. We're
Yeah.
from, where's Landon? We're from Clymer, New York. We're the Pirates. And our bridge, well, we have a private client. He's very wealthy and he really likes biking. And he's got this weird place on his property where it kind of like swoops down and swoops back up. So he's just going to be able to bike right across the narrow top. And he wants to call it the Razor. I don't know. He might have invented the Razor or something. I'm not sure. But it's
I like it.
really sturdy and we figured he has lots of money, so we used as much hot glue as was humanly possible.
Mhm.
Wow. All right. Nice job.
Like it. Good job, guys.
That's unique. I really like that.
All right, so we're from Clymer, like everyone else that has gone. And we did a Pratt truss bridge. We just, did a lot of supports. We did a lot of supports on the top, and then the bottom looks very pretty. We did some
Mhm.
support beams across the bottom so that it wouldn't fall. And then pretty much that's it. We have a little road. It's nice and smooth right there. That's my
What
favorite
did you
part.
use as your road?
What?
What did you use at your road? I think the dowels.
Oh yeah, they're just
The
dowels.
dowel?
Okay.
Okay, that's something that's different compared to the other group, the Delta, which they only had the cross bracing, but you guys have that and also have the dowels, so that should maybe give you more like ductility as well. So
Mm-hmm.
good job.
That's a beautiful bridge.
Nice job.
Very much.
Excellent job. Yeah.
Thanks, ladies.
So I think we got like a couple more because I know that Schnee Learning also wants to share with us.
My name's Maisie. This is Shayla. This is Chucky, and this is Sue, and we're from Kenmore West in Buffalo. And this is our truss bridge. We used popsicle sticks and the dowels.
That was-
Stabilize it along with tape and a lot of glue. And we used a lot of tape to like wrap it and secure it. And we did numerous layers on the bottom. So like underneath, there's a couple different layers of popsicle sticks to make it like stable. And then we did triangles to equally like hold the weight of the top and secure it. So that it would be more stable. And we used a lot of hot glue.
That's
Love
great.
it. Amanda, what do you think of that bridge?
I was gonna say it looks very durable. I love what you did with the tape on the girder or like where the road is. I think it also adds a lot to the aesthetics that you have like kind of the tape color incorporated with the orange and the yellow. I just think it adds a lot to the aesthetics of the bridge. So great job with that and with it looks like
Thank you.
as well.
Well
Good job.
done. Well done, guys.
We
Oh.
know you want to go to some other schools, so if you
Yes,
have
so we'll come back.
Buffalo State, we have some more
Absolutely.
bridges to share, but we'll do some testing while you all are going to other schools.
Amazing work, Buffalo.
Sounds good. We'll come back to you. Now I know. Oh, I see you. Ohio.
Oh.
Uh-huh.
Are we going to Schnee Learning? I know they want to share.
Yes. There they are.
Hey. Good morning, everybody.
Talk to the laptop.
Good morning.
Good morning.
Hi.
This is our truss bridge. We use popsicle sticks for our road, and we did supports with the dowel rods.
Mhm.
And then We already did our testing with the weight. We held 45 pounds, and we couldn't fit any more books in our bucket, so we just stopped it at 45 pounds.
We couldn't fully test it, sadly.
And then we used tape for our road on top of the popsicle sticks. And yeah,
Looks
Sadly,
good.
the hot glue came apart, which made it much less structurally sound for the heavier weights, but it still held up to 45 pounds unstructurally sound because half the hot glue started breaking.
Yeah, that's an
Looks good.
important point that you mentioned because that was brought up in the breakout room as well, and a lot of the failures end up happening at the joints or where you connected them. So it's important to always add a little bit of more reinforcement in those areas. But good job, guys.
Thank you.
Thank you so
Thanks,
much.
Who else is sharing out there? Amazing work. Good work.
Job, guys.
Well done. Now I am going,
Kenmore West, is that what?
let's see.
And Camille Horahan.
Yeah, if you're
Well-
ready to share, just turn that camera on so we can spotlight you here. Okay, let us know. I see Riverdale Baptist. Let us know if you have one you want to share, or Whitnall High and Milwaukee. And then we will go back to Buffalo State after our other volunteers. Ms. Horahan, if you're ready, just turn that camera on and I can spotlight you. Looks like Whitnall Hall is coming up.
Oh, I'm sorry. Can you hear me now?
Yes, we
can.
can hear you. We can't see you, but
Sorry.
we can hear you.
That was my mistake. Oh, you want to see too? That's true. So who's going to do this for me? Who's going to show? Here, I'll hold it.
There we go. Awesome.
So-
We can see you.
All right. So we have two different bridges we're going to show. I swapped the camera on this. It's good. So we're just gonna be very shy. So we're just gonna show you that first, and then we have another bridge.
Okay.
I
You
guess
guys
they
tested or?
Make your guys tell me what you did. You know,
A bridge.
with triangle slash. All right, so.
Wow.
Anna?
Looks like it's holding up pretty well.
Uh-huh. Still holding.
Let's try to find objects.
I'm liking how innovative you're getting with the weights. That's pretty awesome.
Nice job. Do we have anyone from that group that will come up and talk to us a bit?
No, they're all running away, they're very shy.
They're shy. Okay.
Another group. Ready,
Okay.
girls? I think they'll.
Amanda, what do you think about loading from the top as opposed to loading from the road deck?
I think that's kind of a creative idea. I think it kind of indicates how a car might drive over the bridge a little bit. I think it distributes the load a little bit differently than from the bottom, but I like the idea to do it from the top.
Yeah.
Oh,
wow.
Speak about what you did.
That is a very nice bridge.
That's a nice looking bridge.
We use tape for the middle, and like skewers to like sturdy the middle part. And then we just went for the. That's about it.
Amanda, what do you think about that bridge?
I'm excited to see this one be tested. It looks like you guys have
Yeah.
great attention to detail. I mean, all of the trusses are just looking so pristine, and I like your idea to tape both the top and the bottom with dowels just to kind of reinforce it a bit. It looks like it has a lot of places for redundancy.
Looks sturdy, right? Really sturdy.
I like that this one you can actually see the symmetry in it, right? Which is kind of pretty cool, right? Because you don't see it so much with other ones, but this one you can really see the symmetry. So congratulations. I don't know what else you might be able to get that Pepsi bottle on top to add some more weight, but yeah, it looks good. Good job. Amazing.
Great job.
Excellent.
Thank you.
Thanks for sharing with us. All right. Who's up next? Who wants to share? we can get ready to go back to, oh, I see you, Whitnall High. You gonna talk to us?
Hey guys, this is our bridge right here. You can really see it. It's
Yeah.
popsicle sticks and a lot of hot glue. We have some dowels. We have a 25-pound in this bucket right here.
Okay.
Should be able to work.
Wow.
Cool.
All right, it looks like we have a little bit of movement there on the bottom, but holding
Yeah.
up well.
But that's okay, right? Like, so
Mhm.
what do you think? What do you think attributed that? Is it because the glue didn't set? Did you not use tape? What do you
It
think?
looks like the glue on the bottom here kind of,
Mhm.
we were kind of trying to go too quick at the end. So kind of the glue here wasn't glued well enough, but the
I
rest
like
of the
what you
bridge
guys
held up
did
pretty
there with
nicely.
like having multiple different members because you could kind of tell like one of them gave out, but then the rest were still holding up.
Yeah.
So the whole
And the
bridge
ones
is
on the other
fine.
side over here, these ones held up pretty well. It was just the ones on the front that kind of moved. So we could probably do a little more weight if the sides weren't moving.
Yeah, have a little more time.
Is there a reason why you didn't use tape? Because that might have held it a little bit better.
We just like using the hot glue.
Yeah,
That's pretty much it.
Sounds good. Sounds good. Yep. Sounds good. Amazing job, guys. Good job.
Good
Thank
job,
you so
guys.
much for sharing. Yeah.
Well done. Do we have any other volunteers before we go back to Buffalo State? Okay, at any point, just raise a hand, turn on that, turn your mic on or put it in the chat if you want to share. Joanna, we're gonna come back to you at Buffalo State. Can you guys hear us? Oh, look at that bridge, you guys.
Looks like they're right in the middle of testing.
Oh, they are in the middle of testing.
Grab that mic, Joanna.
We're there. We couldn't break this bridge with all our weight, and so we've now added 2 bags so we can double the weight on them.
Wow.
Do you know how many pounds we're at?
I got
That is
the team with was that the horseradish? Yeah, we can't break the bridges here. These bridges are so good. These students are amazing bridge builders, and we don't seem to be able to break any with our testing requirements.
okay.
Indestructible.
Come on.
That might mean that we have to figure out how to test them differently.
I want somebody to talk to us about that design.
Joanna, how much weight is the bridge holding right now?
Our school's color is black and orange. That's why. Yeah, we're from Amherst Central High, and our bridge's color is orange because it's the theme of the school. It's a pretty strong bridge.
Love it.
You're not kidding.
And you guys know how heavy these bags of bottled water.
That's crazy.
I like how excited she's getting. She's like, keep going.
It doesn't look like it's giving at all.
At all, yeah.
It's not even deflecting at all.
No. Wow.
Now, did you guys
Something
consider
I've
like
noticed is that a lot of students like using the hot glue, but like they overlook how strong the tape can be. But that's awesome to see.
agree.
Those bags
definitely agree.
are full. Look.
I can't believe this.
Wow.
Now, go ahead.
I
Did
think
your
we're
team
gonna
consider
go around
cost? Did you guys think about cost, or do you think it's like, did you add too much material, or what do you think? Amherst.
Material, I think we've been a bit overboard on the materials, but I think it gets the job done.
Yeah. I was
I
gonna
agree.
ask a similar question. Were you guys able to compare costs with any other groups around? Just kind of see how you fit in the range of different costs and materials that went into the bridges?
Yeah. We didn't compare the cost yet, but I think it's still pretty good, depending on the materials we use.
Yeah, that might be an extra challenge to add in if you guys were to take out any type of material and see how you can maintain the strength of the bridge just going forward if you want another challenge.
I think the wolf pack wants to challenge them.
I believe we have the what was the name of the
Bridges by Faith. Bridges by Faith.
Bridges by Faith.
You
intense claims. We came out here, we said, hey, we're going to come out here and compete, and not only compete, but we're going to win. And that's exactly what we came here to do with the Faith Bridge. You see this zip tie? This zip tie broke before our bridge failed us. We had so much faith
Wow.
in this bridge that the zip tie couldn't withstand our fate.
I
This
like
has
it.
to be the captain of the football team. I see the football shirt.
You can see the bridge is still unfazed. You could put more weight on this thing. It wouldn't waver. It wouldn't waver because our faith is strong.
I appreciate
Very
it.
impressive.
Textbook books,
Nice
2
stuff.
cases of water. Faith Bridge, everybody.
Good job, guys.
Faith Bridge it
Love
is.
it.
Good job, gentlemen. Good
Love it.
First state. I don't think we can improve on that final commentary. So thank you so much, Edgar.
Thank you. Joanna,
Amanda,
thank you so much
thank
for
you.
being out
See a
there.
little bit of a
Buffalo State did a
sway in the
wonderful job.
bridge.
Ooh.
Oh yeah.
Oh, the one that's out there is starting to
Yeah.
the one that's there
That was a little.
starting to
Mhm.
buckle a little, right? You can see it's going, what is that, leftward, I guess? I like that they're taking video.
A
That's
little.
smart.
Yep. Wow.
That is very smart.
Great job, you guys. Do we
Great.
have
Okay.
anyone else?
Anybody else?
Okay. And if you guys want to continue to talk, Edgar and Amanda and Romina, I'll let you know if anyone pops in that wants to share.
So, I think that I'm going to start asking questions. So, I know Romina and Amanda are getting ready to graduate, but Amanda, what's some of the things that you find challenging about schoolwork and life fun balance, right? Because I think that's kind of hard to do when you're an engineer. Engineer takes a lot of your time, right? So,
Yeah, that's a super great question. I would say definitely when you're in like an engineering curriculum in college, it is very time consuming and I mean it requires a lot of effort to do well in. But I also think it's very possible to kind of maintain a good like social life and be able to get participate in a lot of other fun activities. One piece of advice that I would suggest is getting involved in extracurriculars that do kind of like incorporate aspects of engineering or your major. That's something that I really enjoyed doing throughout college. I got involved in the Society of Women Engineers. It was great to kind of make more friends within engineering that, share similar passions and aspirations for the future. But then it's also just super fun to kind of hang out with them and get to know people outside of the engineering world as well. And then I also got really involved in Engineers Without Borders. So just getting involved in those clubs where you can meet other engineers and have fun with them outside of class as well. And there's also plenty of time to, do other activities that don't involve engineering. I think it's very important to make time for those things, which requires a lot of good time management. So you're staying on top of classwork and everything, but making time for other activities and other friends outside of the engineering world, it's definitely worth it. I would say there's always time for both for sure.
awesome. Thank you. Thank you. Romina, so I understand that you're also getting a Spanish degree. Is that right?
Yeah, that's
You're
right.
getting a Spanish degree. So I mean, that's exciting. And that is, I mean, I know how hard that can be, but question. So, um, languages and then math, were you always good at both or were you better at one? I guess a lot of students that want to pursue engineering, they get scared because they think they have to be excellent at math. And I like that you're showing that you can do languages and do engineering. So what are your thoughts on that?
That's such a great question, actually. When I was in high school, I definitely questioned my ability to, I mean, I took AP Calc, but I didn't go too much further than that. And so a lot of times I did question, I was like, oh, well, I'm not the best at physics or I'm not the best at math. So am I really able to be an engineer? And honestly, anything like I think that you set your mind to, you can achieve, especially because a lot of these things take practice and it doesn't have to necessarily come naturally to you. It just has to be something that you are passionate about and you're willing to put in the effort to learn it and put in the time to learn those materials. So, it's definitely not something to be scared of. There's going to be times where you're not going to get a concept immediately, and that's why you have professors. There's resources you can go to and learn. So definitely not something to stop you from like going and pursuing that.
Gracias, Romina. Es
De
importante
nada.
que ellos escuchen que no es tan difícil hacer lenguaje y matemática. ¿Listo?
Yeah, no, it's
Un
not at all.
proceso. Thank you. Thank you. Amanda, what's one of the hardest things about engineering?
I honestly would probably build off of what Romina was just talking about a little bit right now. I think that one of the hardest things is that like a lot of it might not seem to come very naturally to you. Like just like you said, like physics, that was one of the classes that I struggled through the most. And it can really feel like, oh, I'm not great at this class. Like I'm not cut out for engineering, but really it is just like building all those building blocks to be able to kind of produce a final product. And it's not super important that you're amazing at like a physics class or a chemistry class, but it's really about learning how to learn through those classes and approaching things from more of like a problem solving stance. If you have those problem solving skills and you are a hard worker, like you really can get through those classes, even if it doesn't come super naturally. And yeah, it's really about working hard and putting the effort forth, and you can finally get the degree. And then a lot of it is learning on the job, honestly, for a lot of engineering jobs. So for me, it was all like learning more about learning and how to approach big problems, especially when there might not be like a straightforward answer. I think that's a big aspect of engineering too, is it's a lot of outside the box thinking, and not necessarily like one correct answer, which can feel really hard to approach from the get-go. So
And I'll just add a quick thing of not being discouraged, because that's really what engineering is. You try it so many times and different, like you approach something in different ways and it might fail like 99 times, but then it's the 100th time that like you really get it. And then that's honestly what matters. So it's just kind of trial and error, learning and not being discouraged. Just keep going.
yeah, that's
I mean, for me, it's like we planned it. Like, that ties us right into our keynote speaker, right? Because he has a lot of experience engineering. So I am gonna pop up a slide here. I don't know if you guys can't see yet, but I'm gonna introduce Nicola because I think that what you said was important, right? Nicola is our keynote speaker today, so I'd like to welcome him. I'm excited to introduce him. He is a structural engineer with passion for bridges that has taken him all around the world. He's gone from studies in Moderna, Italy, and gone to Rwanda. He's currently a corporate manager living in Italy, right? He spent 5 years in Kigali, and he's served as an engineering manager and now continues. A fun fact about him, just like one of our engineers, he's studying a language. So with that being said, I will pass it over to him. Nicola, welcome. I am so excited to hear what you have to share, what bits of knowledge you have to share with us today, and a little bit about what you do.
Thank you so much for the introduction, and hi everybody. I'm excited to be here once again and repeat the experience of last year. Can you hear me well?
Yes.
Perfect. Okay. I'm going to start sharing my screen because I want to tell you a little bit of my story and the story of the organization I work for through a presentation. So let me know if you see everything fine. Good.
Yes.
Looks good. Looks good.
Fantastic. So yeah, as you were saying, there is a lot of engineering in my story, and I'm gonna tell you about that. But first of all, thank you again for having me and giving me the opportunity to share my story here. It's always exciting to hopefully inspire some future engineers. So I'm Nicola Turrini. I'm from Italy, the place of pasta, pizza, and all of that. As you all know, there is a small town called Modena in the north. That's where I was born. And that is where when I was a child, I got my passion in dinosaurs and Indiana Jones. So in between these two things, I wanted to be a little bit of a paleontologist or a little bit of an archaeologist, and had a lot of curiosity and adventure in my young age. But then teenage years kind of like came in and wiped them off for a while. Got a little bit of finding my own path, which brought me at a certain point to choose the engineering path. And and after high school and this teenage years period, like I just found myself to decide to go to a bachelor degree in civil engineering, in the same city I was living in Modena, and studying the Unimore University. And that brought me to then decide to take a master degree in structural engineering after that, which gave me the opportunity to spend 6 months in Madrid through a scholarship. And that started to bring back a lot of adventure together with the curiosity of engineering. So curiosity and adventure came back through engineering. And Madrid really opened my eyes to what the world is and how big it is compared to like the little town that I was living in. And so I decided to go back and then become a design engineer in a company that was called and is called Vector. And that's in that same company. That's where I have learned my my skill of bridge design. So I learned how to design bridges, which is what I started loving it. I started loving it so much that at a certain point, I decided to look for more purpose in the way that I was doing engineering. And that brought me to find the organization I work for now, which is called Bridges to Prosperity. I'm going to tell you a lot about that organization, but basically we build bridges to connect rural and isolated communities to essential services. And that decision in 2016 brought me to go as a volunteer in Nicaragua. So I bounced from Italy to Madrid and then suddenly Nicaragua, 1 year as a volunteer, building bridges with my own hands and learning how to really, put together construction pieces rather than just designing them as I was doing in Madrid. But after that year, because of my engineering experience, I've been offered a job with the same organization in Rwanda. So since 2018, I started living in Rwanda as engineering manager of the Rwanda program. And that's been an exciting adventure that lasted for about 5 years, the Rwanda adventure. So I lived in Rwanda between 2018 and 2023. Rwanda is a small little country in East Africa. So it was another big change from Europe to Central America to East Africa, but that's been a fantastic 5 years of my life. Started as engineering manager, but then I decided to change a bit and go into being a corporate program manager, which focused more on finding partners in the construction and engineering world, in industry, that support our mission. So very different, but because of my engineering skills, I could talk to these partners and convince them to join our mission into building bridges to better lives. So that's what I kept doing, bringing partners to support our work in East Africa and inaugurate bridges with them. And I'm going to tell you a lot about these bridges, so don't worry if you still cannot visualize them. But I also, in Rwanda, found my family. I found my wife, Claire, from Nebraska, who already adopted her and now our son, Francois. And now we are a family of 3 back to Modena. So back where it all started. Since 2023, we moved back to Modena, still doing work with Bridges to Prosperity as corporate manager. So still looking for partners from here to support our mission in East Africa. But now let's go into Bridges to Prosperity and let me tell you about our work. When I do that, I always ask everybody to just imagine and take a second to imagine in your life if you had to risk it every single day going to school or to work or to the hospital that could be on the other side of a flooding river. That's how that's how in Modena they were living in the 50s. So my grandparents were experiencing that kind of things with the Panaro River, which was flooding very often. And they had to hang from a cable and moving with pulleys to go to school every single day. And that is unfortunately how still today millions of people are living, in particular in the continent of Africa. And just because of a dangerous river, they have to risk their life just to reach school or the market or the hospital or any other, essential service that could be on the other side of a river that sometimes floods and block the passage or makes it very dangerous. And these are rivers that look like this when they flood. So they can really wash away anything that goes in their path. And again, this is how 1 in 7 rural residents in the world are living. They're cut away from markets, jobs, schools, clinics, and hospitals because of the gaps of the transport networks. So in Bridges to Prosperity, we have a vision. So we envision what can be in the future, and we envision a world where the poverty that is caused by rural isolation no longer exists. And in order to reach that, we build bridges together with governments and these isolated communities in order to connect to essential services like education, healthcare, and economic opportunities. The ones that you can go on a daily basis without even thinking. And these people need to think if they want to risk their life or not, if a bridge is not there. We have done this for a long time, more than 20 years, and connected more than 3 million people with more than 600 bridges. And we keep building. So it's an exciting, big mission. We want to connect millions of people to what they deserve. And we also know that our work, because we study the impact of our work, produce incredible results. We see that the farmers of the communities that we serve actually increase their farm profits by 75% just because the bridge is there, and they can cross it on a daily basis to go to the market and sell their crops or invest more in their crops. The girls of the communities that we serve actually increase their attendance in school by 200%. It means that if before the bridge there was one girl going to school, after the bridge there are 3 girls going to school. Why? Because the parents decide to send them to school because they don't have to risk their life. While before they would decide to keep the girls home and just let them help in the household or just like become a farmer without investing in their future, which is incredible. And lastly, the income of the families in these communities increase averagely by 30%. It means that they will have a 30% increase in their salary averagely. And this is just the tip of the iceberg. This is to show that, I don't know if you know the Sustainable Development Goals, but these are goals defined by the United Nations that all the world is working towards, and our bridges tackle 10 out of 17 of those. So they really help transforming the life of these people in many different ways. We have a focus on East Africa, as I was saying earlier, where we work in Rwanda, where I lived for 5 years, Uganda, Ethiopia, and Zambia. But what do we build? And that's the part, the exciting part, the engineering related part. We build what we call trail bridges. We don't call them foot bridges because they serve people that travel by foot, but also by bicycle, motorcycles, and small vehicles. Anything that can pass in 1 meter of walkway will pass there. Even animals, even cows cross our bridges. Isn't it crazy? And we do that because they are cost effective and durable. They are easy to build, maintain, and replicate. So we can teach the local government and engineers how to build them and maintain them. We don't do it alone. And they're currently rarely considered. So we're bringing something new and we're explaining why it works. And also we leverage locally sourced and repurposed material in order to build it, which is very, very cool. Another way to see them or to describe them is that they are wire rope cable bridges. So as you saw, they're very specifically made with steel wire rope cables. And they are, why did we decide for that design? Because they can reach long spans. We can make them long enough in order to stay away from the river path and not, suffer from the erosion of the banks. And that's why we went in this way and with this type of design. So we can build them like very long because they are very light structures. And here are some examples of our standard type of bridges, which is going to be the interesting, engineering part. This is a suspended bridge, what we call suspended bridge. There are two big and heavy abutments at the side of the bridge, made with rock and concrete, that from which there is a walkway made with cables and a steel walkway that hang from them in a hammock shape. And you can see here the blueprint of the bridge. You can see how long they can be. This is 132 meters long. I think that makes it probably 450 feet long. It's a very long bridge. And that's because the walkway part here on the right is very light, only with cables, the fencing, and the decking in the bottom. And then there is the part that gets all the weight, which is here in front, the foundation with some tiers. So there are like layers of foundations with a concrete tower on the top. And then in the back, you can see at the bottom, there is an anchor beam where the cables are connected. And finally, we build a ramp to connect the anchor to the foundation in front. So that's more or less how this type of bridge works. And it looks like this. It looks just gorgeous. This is the same bridge, the 132 meters long that I showed you earlier. It's in Rwanda. It was 30 minutes drive from my house in Kigali. And then we have a suspension bridge. This is more iconic. You can recognize the shape. You can think about, the Golden Gate Bridge in San Francisco with two tall steel towers that raise the walkway in order to fit in a flatter river profile. And you can see there are like some anchors in the back. So these two goes down with two arms, and at the end, below the ground, there will be another anchor beam, which goes transversely. You can see it a little bit here. This is the blueprint. And here are all the details. You see again, the light walkway on the right, made in the same way. Just having higher hanging cables in this case. Then there is a steel tower that is is weighing on top of a concrete pedestal on top of the footing with a ramp to reach the level of the walkway. And then the cables go back to an anchor system. And that's what you saw earlier. And it attaches to the block on top, but then the force is transmitted with the arm down to the bottom to this anchor beam. You can imagine it is long transversely, and it transmits the force that gets stuck down in the ground. So that's how these bridges work. And here is another example. This was the Nyakabuye Mogo bridge. Very long one as well. I think it was 118 meters long, so around 380 feet or something like that. And this one was a little further. It was a couple of hours from my home, and it needed a long hike to reach it, because these bridges we build them like in very rural settings, away from like the a lot of them are very, very far away from the street. And so you need to walk to reach these places and go to the rural communities we serve with them. Then we also found a very cool way to put the two types of bridge together, which is very exciting and very engineeristic, if you want, because a lot of times we would have these topographies, so these valleys where one side of the river is very much higher than the other one, and neither of the other two types of bridge would fit in that occasion. And so we said, like, why don't we put a suspended abutment on the high part and a suspension tower in the bottom? And that's what we started doing. And we started being able to actually build this funky looking bridge, but very, very efficient. And we have been able to build bridges where before we could not. So this was a major and very understandable engineering tweak that we found, and I'm really proud of. Look at how funky it looks, but it's so, so good. I wanted to briefly tell you also what happens, like you saw the final product, but in order to reach that final product, you really need to pass through different steps. And the first one is to assess where the bridges are needed. For example, we did that in Rwanda in 2018, and we sent out a lot of assessors to check 1,500 sites, and they came back with the information, and then we checked where we could actually build, and we found a list of more than 300 bridges that we could build. So once we identify where we need and can build, then we send out our engineering team to do a survey. They use a topographic instrument that is called either an auto level or a total station. And these instruments are able to identify points on the ground that then can recreate the profile of the valley on a computer. So then you can actually decide how to design your bridge in a computer rather than on site. So once we have that information, we create the drawings, the design, and we count how much material is needed for these bridges. Also, I wanted to say, stop me if I go a little too long, or give me like a 2 minutes heads up, so I can wrap up if I'm like a little too long. And so once we have the design, the drawings, and the quantities with the cost of this project, we sign a contract with the local government, which is always involved in paying part of these infrastructures. So we never come and just build. We always involve the local government, because they are going to be owning this public infrastructure. And then we go to the community. We send our construction team that hire the local community and build the bridge. together also with the government. So we involve the people that are gonna be served by the bridge into the building it. So that's very beautiful. Okay, now I'm gonna tell you a little bit more of like how we designed them. And in order to do so, or how we choose like where to design them, in order to do so, I wanted to define some names and definitions so that the river flow direction goes from one point to another. And so that defines where the upstream is, so where the water comes from. The downstream is where the water goes to. The left is when you get the river direction and flow towards up in the drawing, and the right consequently on the other side. And then there is the one thing that we call the bridge center line. You can imagine if the bridge was just one line, that's where the center line would be. And so that's what the engineer needs to see when he goes or she goes to the site when the bridge is not there, where they're going to see a line and they're going to decide where this line is. And that line is going to be the center of the bridge. So talking about this center line, we really want always to position it close to the crossing point. So all of these communities will have a point of the river in which they currently cross one way or another, because they need to go on the other side. And so they will decide to risk their life in order to do it. And sometimes they walk on a log, like in this case, and that log can be washed away by the river or can fall in the water. It's very, very sketchy. Or sometimes they would even need to swim in the water and they would risk to drown. So in any way, they would cross somewhere. And so you want to put the new bridge close to that crossing point in order to have these people continue with the habit of crossing in that point. Then when you go there, you will need to find good places for the footings and the abutments, depending on what type of bridge you have. And that will define where the center line is going to be. So you imagine you're looking around and you need to find a place where there's enough space for the abutments and the footings, and that will define how to choose the center line. Another thing that will define that is the quality of the soil. But because we work in very rural settings and all by hand, not with machineries, we can just like do a pit. So we dig a hole and check with a visual assessment. And we have very well-trained engineers that can assess if more or less the soil is good. Why the soil needs to be good? Because the weight of all the bridge is going to go on top of the soil. And if the soil is bad, this soil will just crash and go down. And so the bridge will start deforming and might even fall in the river. So you really need, it's really important that you check that the soil is of good quality. And then we also need to understand the history of the river, because rivers are very difficult to understand, and there is a lot of engineering behind understanding rivers. There is an entire section of hydrology in civil engineering schools that is very important, very complex. But yeah, we need to study that and how we do our hydrological evaluations. Well, we start looking at the banks. You see, the banks of the river may look like with a lot of signs of erosion, and in that case, you need to, be really careful, because you know that this river is probably going to continue eroding this part and like, you know, probably going beyond this part. And so you need to build this bridge. If you build it on this center line, you're gonna put the abutment very far away, because if not, one day it might fall in the river. And also with this in mind, when we look to build a bridge, we might think that we need to build a 50 meters long bridge. If we look just close to the position of the center line. But if we zoom out, you see that this, you can imagine here is upstream, and you see that here there's a curve of the river that with the force of water can be eroded. And if it's eroded too much, then it can go and cut the line of the bridge. And so suddenly you need to build a longer bridge in order to consider that possibility if you want the bridge to survive for decades, which is our goal. What else? You need to avoid confluences where multiple rivers get together, because there is a lot of energy there, and like all the rivers like jump here and there, up and down. You just never know what's gonna happen there. So you just don't want to build close to those areas. And finally, you want to understand the high water line, which is the line that defines the highest level that the water reached in the past. How do we do that? So when you do a big bridge project, you actually do a full hydrological simulation and study and look at all the past information and try to guess with all of this information. But we don't have all of that. We are in very rural communities where rivers are smaller and nobody really has information about that. So what we do is we ask to the old people, to the elders of the community, and they will know where the water reached back in the days in the biggest flooding they had. And we can compare that information with, you know, what's around us and consider if it's good or not. And on top of that, we want to also consider what we call a freeboard. So we never put the deck of the walkway right on top of the high water line. We want to pull it up even more, because you know what, the water, when it floods, can bring a lot of debris with it, a lot of like trees and stuff, and they can get stuck and hit the bridge while passing through. And finally, as I was saying, we want to leave a lot of setbacks at the side in order to consider for possible erosion of the banks. And you know, the first part, which I don't have photos here, sorry, but there is a lot of excavations happening by hand. You know, a lot of people excavating to build the foundations, so the abutments or the footings, and then, you know, once we have the abutments and footings in place, we start hanging these famous wire rope cables that are made with steel wires, all like tangled, like it was a braid. And these are connected back to the anchor, as I showed you before. You see, like bottom in the top left, you can see the anchor. This is like a concrete anchor that is casted at the bottom of the ramp that I showed you before, and we are connecting the cable to that. Then here you can see there are the swings that are going to be launched from each side. And this that the guy is painting, bottom right, is the concrete tower on top of the foundations. This is a suspended bridge, of course, I didn't say it. But you see there is a lot of rock moving to fill up the gap in the ramp once the cables are in place. And you can see you top it up, and then you finally close it with a concrete slab. All by hand. You can see there's no machinery, so it's a lot of hard work, let me tell you. And then once that is ready, we can start working at height and actually building step by step and panel by panel the walkway on top of these bridges. And you can see you're hanging on top of the river, like multiple meters above it. And it's a pretty sketchy job, but it's also amazing. It's very satisfying. And you can see there are two teams. One comes from the right side, one comes from the left side, and they're going to meet in the middle and close the gap. And from that time on, the walkway can be used, and it's amazing. Then you can put the fence on to just close the gaps at the side and have fun with all the kids that always surround us when we build bridges. And finally, you can inaugurate the bridge, which is a beautiful and stunning suspended bridge that is going to be there and serve these communities. It is designed with big safety factors in order to last for multiple decades. So that's the goal. And you can see here is an example of a suspension bridge with a big inauguration with all the community coming down and going to load test the bridge like right at inauguration. But this is just beautiful, and it's all to say at the end of the day, I'm finishing, Edgar, thank you. All to say, this is about providing safe access to just normal people that want to go to normal places. This is what bridges do. Take a second and imagine how many bridges you are actually crossing every day, going to work, going to school without even realizing. And what would you do if they were not there? Going to the market or to the hospital and every hour. And this is, for example, Charlotte in Rwanda. She's a mother of 3, and now she's going to be able to send her children to school every single day without worrying about them arriving. Ultimately, I want just for you to know that safe access is a human right, and it's important to remember that. I finished this. You can find Bridges to Prosperity anywhere on the internet, and I'm now able to answer a lot of questions that might come through.
So, Nicola, I am impressed by all of the work that you've done. I mean, it's amazing what you've done, and it's a great conclusion to our Bridges Day, right? Because just like in the introduction, a lot of our students take Bridges for granted, and when you see it have this much impact in the world, it's really, really important. So, I wrote down a couple of things that you were speaking about, and I just want you to, maybe add on if you want to. I'm gonna start sharing my slideshow, which I have here. But part of what I think you're sharing slide. You have to, yeah, there you go. So part of what we do as teachers and educators and people who do this for a living is we're lifelong learners. We're always needing to learn, right? Everyone needs to learn. So today you taught me that trail bridges are 1 meter wide, right? And they're not just for people walking, right? But what I think that you touched on was that passion and what we love is important to success. And I know that Romina spoke about that with the college mentors. I think that it's important. I think one of the things that you said when you became a corporate manager was that you communicated and networked with a lot of people. And I think that's important because engineers need to know that their non-tech skills, what we call their soft skills, are just as important, right? You were able to communicate with these people. So writing is important. Being able to meet with people, looking at them in the eye when you're speaking to them, those are important, right? And then I'm taken aback by how you use your skills just to improve the world. That is the definition of the engineer, right? Bridges to prosperity, you bring in all these people access to things that they never had before. I love the innovation, right? That's something that always happens now that they have these hybrid cable bridges, right? And that's because it was required. Necessity, right, is often the mother of innovation, right? And then I like that you talked about the big picture, right? Like you have to make sure that these bridges last for a long time. So those abutments have to be pulled back, right? You have to have the right material. And then hard work, not impossible work, but hard work. And that's important for everyone in this world to understand. Then I like that safe access is a human right. So, I mean, thank you so much for today. I want to thank everybody on this call. Nicola, do you have any final words of advice for anyone that is looking to pursue civil engineering?
I think, well, thank you for having me again. But I think engineering really means the world to me. It really shaped my life in so many different ways, brought me to find my real passion, and gave me, engineering is a tool that you can use to achieve things that you want in life in many different ways. And if you study engineering, as you see, you can also become a manager and actually go and find partners. So it's a completely different thing from what I studied, that were like technical, structural elements of a bridge, but still your brain, after studying engineering, is able to continue learning. As you say, long life learning is a key element of any engineer. So yeah, keep being excited, because if you choose engineering, it means that you're already excited about things, and that's the trick.
Thank you so much, Nicola. Thank you. Once again, big round of applause, everybody who's out there, for Nicola. Amazing, amazing work. And that, I believe, concludes our Bridges Day. I want to thank everyone out there for joining us today, for sharing their bridges. Again, I am humbled by hearing from the college mentors, but also from Nicola, right, who's done all this work. And I think the story about you meeting your wife and family in Rwanda is also amazing. So, I mean, heroes, right? They don't always wear capes, but thank you, everybody. So that is, I'll pass it over to Jillian now. Thank you so much.
Wow, thank you all so much. Last event of the year and went out on a high note. Thank you, Edgar. You did an amazing job leading today. Nicola, it was a pleasure to have you. Thank you so much. Your visuals, your story is amazing. Teachers and students, thank you for being here with us. We hope you have a wonderful summer and look forward to seeing you again in the fall. Look out for that email with a recording of today's full event, and keep learning. Be a lifelong learner, like we said. Have a good one.